Hello everyone, I am Isaac, a talkative data scientist. In this Jupyter notebook, we will be exploring a project done by Samuel N. Namani, also known as Samostinalist. You can find more about him and his work on his website https://samostinalist GitHub. Let's get started. The first cell is a markdown cell that provides some information about the project and the author. It doesn't contain any code, so we can move on to the next cell. In the next code cell, we see that the pandas library is imported and used to read in a sysv file called stress.sysv. This file is located in the directory c/users /max text store /documents /data science projects /personal projects /stress detection /. After reading in the file, the head method is called on the data frame to display the first 5 rows of the data. This allows us to get a quick glimpse of what the data looks like. It's important to note that the data contains 116 columns, so we're only seeing a small portion of the data with the head method. Let's move on to the next cell, which is a markdown cell. In the next code cell, we will perform some data cleaning on the data frame. This includes dropping any rows with missing values, dropping any duplicate rows, and dropping any columns that are not relevant to our analysis. We will also rename some of the columns to make them more readable and easier to work with. After cleaning the data, we will use the head method again to display the first 5 rows of the clean data frame. In the next code cell, we are checking to see if the data frame contains any null values. We do this by calling the isNull method on the data frame, which returns a Boolean data frame indicating whether each value in the original data frame is null or not. We then call the sum method on the Boolean data frame, which returns the sum of null values for each column. In this case, we can see that there are no null values in any of the columns, as all the values in the output are 0. Let's move on to the next cell, which is another markdown cell. In the next code cell, we are defining a function called clean that will be used to clean the text data in the text column of the data frame. First, we import the necessary libraries such as NLTK, restring, and stopwords. We also download the stopwords corpus from NLTK if it is not already downloaded. Then, we define the clean function that takes in a string of text as input. Inside the function, we convert the text to lowercase using the lower method. We then use regular expressions to remove any text within square brackets, any links starting with HTTP or HTTPS, any HTML tags, any punctuation marks, and any newline characters. Next, we remove any stopwords from the text using the stopwords corpus from NLTK. We also stem the remaining words using the Snowball stemmer from NLTK. Finally, we join the cleaned and stemmed words back into a single string and return it. We then apply the clean function to the text column of the data frame using the apply method and assign the clean text back to the text column. This will clean the text data in the text column of the data frame by removing stopwords, links, special symbols, and language errors. In the next code cell, we are visualizing a word cloud of the clean text data in the text column of the data frame. First, we import the necessary libraries such as Matplotlib, Pyplot, and WordCloud. We also import specific modules from WordCloud such as WordCloud, Stopwords, and Image Color Generator. Then, we create a string variable called text that contains all the clean text data in the text column of the data frame. We do this by using a list comprehension to join all the clean text data together with a space separator. Next, we create a set of stopwords using the stopwords module from WordCloud. We then create a WordCloud object called WordCloud and pass in the stopwords set as a parameter. We also set the background color parameter to black to make the word cloud appear on a black background. Finally, we use Matplotlib Pipplot to display the word cloud by creating a figure with a size of 13 by 7 inches using the PLT figure method. We then use the PLT show method to display the word cloud image with the interpolation parameter set to bilinear for a smoother appearance. We also turn off the axis using the PLT axis off method. Finally, we use the PLT show method to display the word cloud image. This will create a visual representation of the most common words in the clean text data in the text column of the data frame. In the next code cell, we are creating a stress detection model for the text data in the text column of the data frame. First, we assign the label no stress to the value 0 and the label stress to the value 1 using the map method. This means that any row with a label of 0 will be labeled as no stress and any row with a label of 1 will be labeled as stress. Next, we select only the text and label columns of the data frame using the dftext label syntax. Finally, we print the first 5 rows of the updated data frame using the dfhead method to confirm that the labels have been correctly assigned to the text data. In this code cell, we are splitting the dataset into training and test sets. First, we import the necessary libraries, CountVectorizer from Sklearn, feature extraction, text and train test split from Sklearn, model selection. We also import NumPy as NP. Next, we create X and Y arrays from the text and label columns of the data frame, respectively. Then, we create a CountVectorizer object CV and use it to transform the X array into a matrix of token counts X. Finally, we use the train test split function to split the X and Y arrays into training and test sets. We set the test size to 30% of the data and set a random state of 50 for reproducibility. The resulting arrays are xtrain, xtest, itrain, and itest. In this code cell, we are using the Bernoulli naive Bayes algorithm to train the detection model for binary classification. First, we import the Bernoulli class from Sklearn naive Bayes. Next, we create an instance of the Bernoulli class and assign it to the variable model. Then, we use the fit method of the model object to train the model using the xtrain and itrain arrays. Finally, we use the score method of the model object to calculate the accuracy of the model on the training data. The output of this code cell is the accuracy score, which is 0.9 quadrillion, 229 trillion, 607 billion, 250 million, 755,287. In this code cell, we are testing the performance of our model on some random sentences related to mental health. First, we ask the user to input a text using the input function and store it in the variable user. Next, we use the transform method of the CV object to transform the user text into a matrix of token counts and then convert it to a NumPy array using the toArray method. We store this array in the variable data. Then, we use the predict method of the model object to predict the label of the data array and store it in the variable output. Finally, we print the output label using the print function. In this case, the input text was sometimes I need to really go for a checkup on my mental health and the output label was no stress. This means that our model predicted that the input text is related to mental health but does not indicate any signs of stress. In this markdown cell, it is mentioned that the stress detection machine is capable of detecting whether a person is stressed or not based on their statement. It is also mentioned that the model can be improved by adding more data to it. In this tutorial, we have created a machine learning model using the naive Bayes algorithm to detect stress in text data. We have used the CountVectorizer class from the scikit-learn library to convert the text data into a matrix of token counts and trained the model on a dataset of labeled text data. We have also tested the performance of our model on some random sentences related to mental health and seen that it is able to predict whether a person is stressed or not based on their statement. To improve the performance of our model, we can add more data to it and also try out other algorithms and techniques for text classification. In conclusion, we have learned how to create a simple stress detection machine using machine learning and how it can be applied in real-life scenarios to help people manage their mental health. Thank you for watching this tutorial.